Project 2.4.1 Breadboard ATmega328P. This project explores the required setup for a detached microcontroller, as well as the implementation of an embedded system for the microcontroller. This is the diagram of the detached ATmega328P. To make use of the microcontroller, the black highlighted pins must be connected to the ICSP inputs, and the blue highlighted pins must be set up to a crystal. With the exception of a couple of other pins, all remaining pins are at the disposal for the system. In this photo, all components except for the TMP36 are set up to the ATmega328P in order for it to operate. As mentioned, the pins highlighted in black go to the ICSP header. This makes use of an ASUS PCB breakout board, which attaches to an AVR cable, which attaches to the computer. While connected to the computer, it can receive instructions from code, and it can also receive the 5 volts of power required to operate. The second option is to make use of an LM7805 voltage regulator, bringing the 9 volts that come from a battery down to 5 volts, which is the recommended operation voltage for an ATmega328P. Keep in mind that only one voltage source should be connected at a time. The blue setup requirement for the ATmega328P is the oscillation crystal and 2 shoulder cap capacitors. The crystal oscillator is a timekeeping base for the stores, vibrating with a frequency of 16,000 Hz. It receives a small level of current from the microchip pin 9, increases that to a much more identifiable oscillation, and then returns it to pin 10. The capacitors and resistors in this diagram are simply there to reduce interference with the crystal's oscillation. To show the microcontroller operating with typical capabilities, the embedded system contains a TMP36 temperature sensor, which is displayed in values of Celsius and Fahrenheit on an LCD screen. Thanks for listening.